A very good day to everybody. Our group, which is Group 2, would like to present about our computer-aided drawing, also known as CAD, engineering drawing, which is better known as our mini project. My name is Dinendra Pubalin with number matrix of 01 FTV 24F1030.
And my name is Rito Lesker, matrix number 01 FTB 24F1028.
And my name is Adam Haris, number matrix 01 FTV 24F1029.
And my name is Ashraf Fizi, number matrix 01 FTB 1059.
So today, we would like to discuss on the introduction and objective of our mini project, the reverse engineering we used, the orthographic projection, and also the isometric projection, the discussion, and finally, the conclusion.
Okay, number 1 is introduction and objective. This project is all about creating technical drawing with AutoCAD, focusing on a few key topics, which are topic 7. In this project, a power bank was digitally replicated by measuring its dimension in millimeters through reverse engineering. These measurements were used to create orthographic and isometric drawing, demonstrating how real-world objects can be accurately converted into digital design following engineering standards and guidelines.
And topic 8 is to keep the drawing clear and organized. Detailed annotation and dimension were added. Different layers were used to separate elements like geometry, dimension, and center line, making the drawing easier to understand and edit. This approach ensured clarity, efficiency, improving the overall visualization of the drawings.
Okay, next is topic 9. The project featured a third-angle orthographic projection and a 3D isometric view of the power bank. Together, these views give a clear understanding of the power bank's shape, dimensions, and how its components relate and complement to each other. This combination ensures easier visualization of the object for technical purposes.
And finally, topic 11, where the completed drawings were saved as PDFs with correct scaling and layout. They were formatted in A3 size, landscape orientation with the drawing centered and the set for general documentation. This ensured the drawings met engineering standards and were ready for professional presentation. The final output highlighted the importance of clear formatting for sharing key technical details about the power bank, making it easier to understand.
Okay, so next is reverse engineering. So what is reverse engineering? So reverse engineering is basically the process of analyzing a product, system, or technology to understand how it works, typically be deconstructing it. It is often used to replicate, improve, or learn from the design or functionality of the object being studied. And it is also commonly applied to software, hardware, mechanical device, and biological systems. So the key steps in reverse engineering, so we have 3. So the first one is disassembly. So taking the product apart to understand its components and structure. And the second one is analysis, studying how the individual parts interact and contribute to the overall functionality. And the last one, we have reconstruction, which is rebuilding or modifying the product based on insight gained. Okay, so as we can see here, this is our model, which is the power bank. So here is the top view, okay, and then this is the side view, and then this is the front view. Okay, so here you can see is our power bank measurement for the front top view, side view, and the front view.
Okay, number 3 is orthography. Okay, the orthographic projection was created using third angle standard with precise measurement in millimeters. Key feature of the power bank like the spacing of the on-off button, USB port, Type-C port, and micro port. We carefully documented. Specified details such as the radius of the Type-C port is radius 1, on-off button, radius 2.5, and body corner radius 8. We also include annotation and center line we added to highlight symmetry and functional dimension. AutoCAD layer feature was used to organize line into object dimension and hidden layer, ensuring the drawing was clear and easy to edit. Okay, this is our plot. This is top, front, and side.
So I'm gonna explain about the isometric drawing. So the isometric is a 3D representation of the power bank, highlighting details like the curved side, button, parts, and the battery display on the display screen. AutoCAD isometric tools ensure accurate proportion and alignment, making it easy to visualize the object depth and size. A dedicated isometric layer was used to keep this view well organized. So the power bank body itself has a rounded cubic with a dimension of 66 by 114 by 27 millimeter, featuring a radius of 8 in arc at the corner. Okay. The front and back has a rounded rectangular shape that match the contour of the power bank's body with the dimension of 64 by 1 by 25 millimeter. This design ensures a consistent 1 millimeter gap between the front and the back of the body at all points. So the power bank display, which is here, the black one, the power bank features a small screen at the top measuring 16 by 28 by 1 millimeter, which display the battery life. So here are the example of the display. Okay, so the button and the ports. So this power bank has an on and off button to control its operation. It also features two rectangular type A female ports, a rounded rectangular type C female ports, and a trapezoidal micro female port. Users can plug charging cables with corresponding male connectors into the port. The variety of ports provide flexibility, allowing users to charge different devices with various cable specifications. So here is our isometric drawing. And this is the realistic model of our drawing. So that's all.
All right, so let's move on with the discussion. So the first thing we would like to discuss about is the type of lines. The drawing uses different types of lines, each for a specific purpose. For example, the object line outlines the shape and geometry of the key, while dimension and leader lines show measurements and annotations. Center lines will emphasize symmetry, which is always important in engineering design, while hidden lines will show clear distinction of objects that can't be seen at certain views, angles, and perspectives. Construction lines will also aid as temporary reference lines to help with alignment and positioning of the objects. By including both the third angle orthographic projection and the isometric views, the drawings clearly communicate the power bank's flow geometry. Next will be the type of projection. As shown in 2.0 orthographic drawing and 3.0 isometric drawing, this drawing combines orthographic projections in third angle perspective. So if you were to look at a quadrant perspective, the first quadrant would be your projection line, 45 degree. Second quadrant would be your top view. The third quadrant would be your front view. And the fourth quadrant would be your side view. This will ensure accurate measurements for the orthographic projection. And it also helps with the isometric projection to show the 3D structure. Together, these projections provide a clear understanding of the power bank shape and dimensions for better comprehension. And next, we have the layer specifications. So as you can see on the picture here, we have about 6 layers that we used. So layer specification is important to ensure efficient organization, where the drawings utilize multiple layers, each named according to its function. Object layer will represent visible geometry. The dimension layer will house all the dimensions and annotations. Center lines were housed in the center layer to emphasize the symmetry and balance, while hidden lines, they will be placed under the hidden layer. Construction lines were stored in the construction layer, and these layers will ensure clarity in the drawing process, simplifies editing, and will meet the requirements also stated in topic 8. So finally, let's move on to the conclusion.
This project showcases how engineering drawing principles are applied using AutoCAD. with a strong focus on following professional standards. By working on topic 7, creating drawing, we accurately replicate real-world objects through reverse engineering, measuring, and modeling. The key emphasize the importance of precision in technical drawings.
Incorporating topic 8, which is annotation and drawing organization, we made sure the drawing was clear and easy to understand. Using multiple layers in AutoCAD help keep things organized, while detailed annotation and dimension improve the communication of the design. This practice align with the industry standard and highlight the value of structured drawing method.
And so, creating both orthographic and isometric projections, as outlined in topic 9, which is isometric and orthographic, give a full representation of the key's geometry. Orthographic projections provided accurate measurements, while the isometric view captured the 3D structure, enhancing the drawing's clarity. So together, these projections demonstrated how combining 2D and 3D views can strengthen engineering documentation.
And when it comes to topic 11, plotting, this ensured that the drawings were properly formatted and scaled for professional use. The final output met engineering standards, making them ready for presentation. Overall, the project emphasized the importance of blending technical knowledge with the practical CAD tools to produce precise and professional engineering drawings, which are of course essential in design, manufacturing, and engineering. Before we end our presentation today, I would like to take some time to explain a quote that was stated by Elon Musk, where he stated that to take things apart, understand them, and then build them better. Now, through this presentation, we were talking about how we took this power bank and we split it apart into its 2D components, right? The front, side, and the top. So when we actually broke it down to its 2D components, it made it easier to get its measurements and also replicate this object back in a 3D modeling, which makes it more easier to understand the object. And if you ever wanted to innovate and modify to make this product better, we make it much more easier. Okay. With that, this comes to the end of our presentation today. Thank you so much for listening and hope you have a good one.
Bye bye.